Okay, this video is to help you with the problems from week 24 homework. So this goes back to what you were learning in 8th grade with the exponential laws or laws of exponents. So notice here you have the same base 6. When you have a product multiplication, you keep the base and you add your exponents. So in this case, if we keep the base, we have 6. 2 plus 3 is 5. So this simplifies to 6/5. It does say use exponential notation, so you do have to keep it as an exponent. So here we're going to simply go 6 to the 5th. Again, you might have slightly different numbers than what I have on here. Again, if you want additional practice, you can always hit similar problem and it'll generate a new question. You also have the feature of view example down here at the bottom, and then an example pops up. So that is very helpful. Here you're going to use the property of exponents to simplify. Again, you have the same base. A fraction is a quotient. So if you recall from that 8th grade section, we keep the base, but we subtract the exponents. It's always the numerator exponent minus the denominator exponent. So that would make it 9 minus 6, and that would give us 4 to the 3rd power. And when you're entering it, just put your base value. In this case, we have a numerical base, and it's to the 3rd power, so I use the exponent button here. Okay, this one is an example of a power to a power. So you should notice there's only a base of 9, but we have 9 squared to the 5th. This property states we keep the base, but we multiply the exponents. So in this case, it would be 9 to the 10th power. And you'll see this build up as we move to the next week's homework and the following, but you're going to apply it in a little bit more complex way. So here we have a mix of a numerical base and an exponent or a variable base. So here it is a power to a power. We have 2x to the 6th all raised to the 3rd power. This numerical base has an exponent of 1. So we have to distribute our power. So this makes it 2 to the 3rd power, and 6 times 3 is 18. So it'd be 2 to the 3rd, x to the 18th. But since we want the simplest form answered, anytime we have a numerical base, in this case, we are going to multiply that out. 2 to the 3rd is 8. And we still leave 16 to the 18th power. So let's see how we did there. 8x to the 18th power. This next example, it says use the property of exponents to simplify. You're going to use 3 as the base. So again, the same base, you subtract the exponents. This particular example would be 3 to the 4th power because 9 minus 5 is 4. You're going to use the property of exponents. You're going to write 3b to the 2nd power as a product of powers. So we do take this -2 and it distributes both to the 3 and the b. Both of these in the parenthesis have an exponent of 1, so we distribute to each of those. So it becomes 3 squared b to the second. So it looks like it, in this case, it would be choice B. Again, if this is something that you're still not quite understanding, I would highly suggest hit similar problem so you can get a few more practices and be a little bit more confident in your answers with that. For number 7, another power to a power. It does say type a whole number. Directions are key here. So we know the base is 2. The exponents are 3 and 1. 2 to the third power would be 8. Let me try what would happen if I would put 2 to the third power. Then I hit check answer and it says incorrect. Then you would read here the little note of why it's incorrect. It says make sure your answer is a whole number. So then that's telling me it didn't want it with an exponent. It wants what it equals. So that would be 8. And then it says nice choice and it'll let me go on. And then it goes to the next part that, because we're analyzing this classmate, they got the incorrect answer of 16. Why is that? So they probably added the 3 and the 1 to get 2 to the 4th, because 2 to the 4th does equal 16. So it would look like maybe their error was the classmate added the exponents instead of multiplied. Here you're going to simplify this expression. Recall that we are going to apply the zero exponent rule. Notice that the base is a negative 7.5. It is in parentheses, so the whole thing is to the 0 power. Anything to the 0 power is simply equal to 1. Here we want the values to be expressed with equal to 1, or is the value of this expression greater than 1, equal to 1, or less than 1? Anytime it has a negative exponent, we're going to use the negative exponent rule. So if we think about 5 to the negative third power, if I write it with a positive exponent rule, I have to bring it to the denominator, make it to the third power, which is 1 over 125. This is definitely less than a whole number, so less than 1, because it is equal to a fraction that is less than 1. So 1 over 1 to the 25th would be less than 1. Number 10 here, we have a coefficient 7 and y to the 0. Because the 7y are not in parentheses together, we can make it 7 times 1, because only the y is to the 0 power and anything to the 0 power is just 1. So this would simplify to just simply 7. This one is a challenge problem. Is the value of this expression, is it going to be greater than 1, less than 1, or equal to 1? So there's a little bit of work we're going to do on this one. The negative exponent rule says if it's negative, we bring it to the denominator to make it positive. But if it is negative in the denominator, we're going to bring it to the top to make it positive. So this becomes 4 to the negative, or sorry, not negative third, but just positive 3. And that would be to the 0 power. But even before that, since the whole thing is to the 0 power, anything to the 0 power equals 1. Another way to justify that is that 0 times 3 is just 0. So 4 to the 0 power is 1. So we should have been able to see it right from the get-go that it was going to be to the 1 or equal 1, because anything to the 0 power is equal to 1. Here we have, we need to complete a table. We are given that 5 to the negative 4th power is equal what as a positive exponent? Well, in this case, it would equal, when we bring it to the denominator, we keep the base 5, but it goes from being a negative 4 power to a positive 4. Exponents mean you take the base and you multiply it to itself as many times as you see in the exponent. So this is 5 times 5 times 5 times 5. If I multiply this out, we have 5 times 5, which is 25, times 5 again is 125, and 125 times 5, let's see, that's 25, 10, so plus 2 more is 12, so it'd be 625. And then the last question, you have 7 to the negative 2nd times negative 3 to the 2nd. When you have this, well, in this case, you have different exponents and different bases. So I'm going to use the negative exponent rule and make the 7 to the negative half, put that in the denominator. So that's same base 7, but now instead of a negative 2, it's 2. I do have a negative base here that is to the 2nd power. A negative 3 times a negative 3 is a positive 9. A 7 times a 7 is 49. It does say type an integer or a fraction. So this would be equal to 9/49. And make sure that every time, once you finish everything, that you do hit submit at the end. Notice that it'll tell you if you skipped a problem or if you didn't answer it. Since I hit similar problem, it's telling me to, or it's asking me to go back and do it again. So I guess if you do hit similar problem, make sure that you do go back and answer that problem. Let me see which one else went unanswered. So this one is a base 3. 9 minus 5 is 4. So give me a warning because I didn't do the check answer. I can also skip all the way to the end. Now I can go ahead and hit the submit, because then that'll show me your final grade.